Hello, welcome to Block 2, Use of Algebraic Notation, Lesson 3. I'll share my screen. So, our lesson today is we use letters to generalize number. So, we use diagrams and letters to generalize numbers. In your previous lesson, you learned about finding the inputs by using inverse operations on the output that is already given to you. Okay. But before we start, I would like you to do a retrieval practice to get you to remember some of the things you learned. I'll give you 4 minutes to get this done. I think 3 minutes should be sufficient for this. So we have 1 minute left. She knows. Okay, let's check our answers. So here, okay, 5 times 3 is the same thing as 3 times 5. I want to introduce a new word that you should take really seriously. And that word is this. So let me spell it. Why we have said 5 times 3 is the same thing. It is called commutative. Well, it's a special maths word Okay, just like I told you in the previous lesson that you should be using the word inverse instead of opposite. So don't say the opposite of timesing is to divide. Okay, use the word inverse. So commutative means that the order of the operation, that's the way it's defined officially, the order of the operation does not matter. So 5 times 3 is same thing as 3 times 5. Well, I'm sure you're thinking that, that's interesting. Maybe addition behaves the same way. Check this out. 2 plus 5 is the same thing as 5 plus 2. So addition and multiplication are commutative. Ah, I know you're beginning to think, oh, what about subtraction and division? Don't just rush yet. We're going to check that in this lesson. We'll see that they're not commutative. But I want you to know that multiplication and addition are commutative. So the order of operation does not matter. You can move what is on the left to the right and what's on the right to the left. You will get the same result. Okay, question 2. You were asked, what is the total value of the bar model? Well, for the bar model, the total value is 28. Now, you're told, question 3, write down how you calculated the total value of the bar model. Well, there are different ways to calculate the total value of the bar model. We could either add them up, so 4 plus 4 plus 4 all the way, or we can say, oh, but we have 4 lots of 7. Or, remember what I just told you from question 1, you can say, it's the same thing as 7 lots of 4. Okay? Really important. It's really important you take note of what's going on here because we're going to be using this even in this lesson. Now, we are getting into some really interesting learning. We're building some really good foundation for understanding maths. Remember, the title of our lesson is to use letters to generalize number. What does that even mean? So look at this jar of sweet. If I tell you that there are some sweets in this jar, but I haven't told you the number of sweets that are in this jar, you're going to say, okay, number of sweets in the jar. I'll say, okay, take away 2 sweets from the jar. Now, instead of saying number of sweets in the jar, which I have not told you, minus 2, we can then start to use a letter. So in maths, we use letters to represent things we don't know. And I want to introduce a new word to you. When we do that in maths, we call it variable. So this X, we could have called it any letter. It could be A, could be S, could be J, could be Z. But a lot of the time in maths, we use X and Y. Okay, so that's the popular thing with people who don't get algebra. They say, oh, I hate algebra, there's so many letters in there. So this X, I have said I haven't told you the number of sweets in this tin or in this jar, but because we don't know what it is, we just say let it be X. So we call this variable. Okay, I want you to really take note of these new words we've learned. So we've learned commutative, that commutative means the order of operation does not matter. 3 times 5 is the same thing as 5 times 3. 2 plus 5 is the same thing as 5 plus 2. Okay, this works for addition and multiplication. Okay, now let's carry on with this. If I now say to you, this variable, we have said we don't know the number of sweets in this jar. Let it be X. It could be A, it could be Z, it could be any of these letters of the alphabet. If I say to you, I'm going to take away 2 sweets from the jar. So now you can see that it becomes really easy to write it out. You say, oh, okay, I know. Because I have said the number of sweets in the jar should be X, we can say, or you can say, oh, to find out what's going to be left or how I need to write it is going to be x minus 2. You see that? What if I say, okay, now let's forget about that. I want you to add 5 sweets in the jar. You would say, oh, okay, because we said the number of sweets in the jar should be x. If we're adding 5 sweets, we're going to write x plus 5. You see, we are getting into algebra territory, eh? Exciting, exciting, I would say. Very exciting. Now that you know that, look at this. If I have this, you can say, okay, to get the amount or the value of these bars, because each bar is worth 4, I just need to, it's the same thing as 4 lots of 5. Look at that. It's the same thing as 4 times 5. Or remember what we just learned, commutative is the same thing as 5 times 4. Right? Okay, what about if I gave you these boxes and I say, okay, what is the total value of this box? Okay, now you're beginning to see how things work. You say, well, I could add up the boxes, but it's the same thing as the box times 5 because I have whatever is in the box times 5 because I have 5 lots of those boxes. Or remember, we can rewrite it the other way. Commutative, remember that word? We can say it's the same thing as 5 times the box. All right? What about if I gave you this? If I gave you this, so let's rub the word variable. Let's rub the word variable off. So you now know that when we see letters in maths, or even when you do science, we call them variables. Yeah? Variables. Now, when this is your own personal assignment, I want you, or you can just Google it right now. What does the word variable means? I'll tell you. It means something that can change. So it means variable is something we don't know and that value can change. I want you to really have that concept. It's really important. The value can change anytime. Okay. So for this one, we have K, 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 K in all of the, all of the boxes. Now remember, we could add all the boxes up, which is K plus K plus K plus K plus K, 5 Ks. We can write it like that, or we can write it like this. Okay? Commutative. Remember that word. I keep using it. I like the word. Okay. Right. What about this one? We don't even need to be adding anymore because we know this is W plus W plus W. There's going to be 3 lots of W, 3 times W. Or we can write it as W3 or W times 3. Now, I want us to get into the habit of doing things correctly. Which one do you think looks right? Should we write this? Which one looks right? Is it this one or this one? Well, intuitively, common sense will tell you, that looks like postcode. When did we start using postcode in maths? Well, I think this one. Yeah. So I want you to start thinking this way. When you write variables and numbers next to the variable, I'm going to tell you what we call the number. Just wait. There is another new word I need to tell you. We need to write the number before the letter. Okay? So let me tell you the word. Yeah? What we call this number, anytime you see a number next to a letter, we call it coefficient. Interesting. This one, the letter, I'm sure you haven't forgotten what we call it. We call it variable. Okay? So it's really important you think about these words. So we've learned so far new words you've learned in this lesson. commutative. It means the order of the operation does not matter. For example, 3 times 5 is the same thing as 5 times 3. It's there is also there is also commutativity. As I've done another big word there. In addition, so 2 plus 5 is the same thing as 5 plus 2. And you've also learned that when you write in algebra, you write the number before the letter. The number next to the letter is called coefficient, and the letter is called variable. These are really important words that will serve you for a long time, even as you study maths and even science. Okay? So when they use these words, it shouldn't be, strange to you anymore. Okay, let's move on. Okay? So we should actually write it as this 3W. Okay, so far what we've learned is you can add quantities together. Okay, you can have, for example, W plus W plus W. That will be 3W, or 3 times W, or W times 3. A proper way to write it is 3W. And you've also learned that commutative means the order of operations do not matter. So 3 times 5, same thing as 5 times 3. 2 plus 5, same thing as 5 plus 2. You've also learned that the number that you write next to a letter is called coefficient, and the letter is called variable. Okay, I'd like you to have a go at questions 1 to 4. I would like you to pause the video and actually have a really good practice of these tasks. So this is question 1. You can pause the video. You should be able to do this in 2 to 3 minutes. Okay, make sure you pause the video, have a practice before you check the answers, before you mark your work. So assuming you have already done that, here are the answers. Okay, so here are the answers. You can mark your work. So you can see, okay, everything we've done so far. So you can see we're using diagrams now, but it's the same thing. That could be a letter. These diagrams for question for C, 1C, those could be letters. Okay, but the principle is the same. It hasn't changed. We do the same thing. All right? Okay. Here is questions 2 to 4. I would like you to pause the video and practice these questions for 5 minutes. You can take longer if you want. So assuming you've already done that, I would reveal the answer. So these are the answers for question 2 and 3. For question 2, you can see you're being asked which one of these bar models represent 4m. It has to be that one. Okay? If we cannot add 4 plus m, that's not 4m. We can't add these. So it's these. So we can add m plus m plus m plus m, and then that's 4m. So 4 more than m. So what do the other bar models represent? Yeah, these other bar models means m plus 4. So if we were to write it, so 4, this means 4 more than m. Yeah, it's important. This is something new you're learning. So this, if I were to add this, it will be m plus 4. So this means 4 more than m. And then this one means, if I add this, this is 4 plus m. This means m more than 4. Yeah, so this is new learning. Take note of that. Okay, because we're going to come across and we're going to use it. And then this one, you have to circle the calculations that are correct. A plus A is 2A is also A2, but we've learned that a proper way to write it is to write the number before the letter. And then you ask to draw diagrams to support your answer. Just draw two bars with A in each of them. Okay, and this is the answer for question 4. Okay. They say you should explain why this bar model shows 2b times 3. Well, it shows 2b times 3 because if we add them, it's going to be 2b plus 2b plus 2b. Yeah. Remember, if this was w plus w plus w, we would say, well, we can write it as 3 times w or w times 3. You remember what we've been doing from the start of the lesson? So we can just do the same thing. We can say it's the same thing as 2b times 3. And then this one, we're told to use the bar model to complete the calculation. Yeah, and that's what it's going to be. 2b plus 2b plus 2b is 6b. Okay? Now, let's do some new learning. If I say to you, D, yeah? So if we have D and we want to find out, we know what D is, but we want to find out what is in each box. What do you think we will do? Oh, I think you may be thinking right now, yeah? I want to think you're thinking, exactly the way I'm thinking. I will have to split, I'll have to divide whatever D is by 3 because I have 3 boxes representing D. So I can write it like that. So each box, each bar of this bar model is D divided by 3. So for example, if this whole bar was, let's say 6, each of these box will be 6 divided by 3, which is 2. Okay? But another thing that is important is how we actually write it in maths. In maths, we will not leave it like this. So remember, when we did multiplication, we didn't leave 3 times W as 3 times W. We wrote the number next to the letter. So we wrote 3W. So in algebra, we write it like this. So the way we would say this is D divided by 3 or D over 3. It's really important you take note of this. Okay, what about this one? By now, you know this because 7 times A will be written as 7A. Okay, don't forget about the new words we've learned. The 7 is called the coefficient. The A is called the variable. What about A times A? What do you think? I'll give you a clue. Remember this from primary school? 4 times 4 is 16. It's actually the same thing as 4 squared. Now, the interesting thing about maths is things will stay consistent. That is how you know you're right. So it means this 4 could have been A and that 4 could have been A. So if we do the same thing here, we can simply just write A squared. How interesting. Very interesting. Okay. What about this? So if we have that, how could we write this? Now remember, in algebra, we already know A times A is A squared, but we're not going to leave it as 7 times A squared. Guess what? We're going to do like what we did when we wrote 3 times W, right? You can see things stay consistent. So we're going to write the 7 next to the A squared. You see? Interesting, right? What about this one? Mo says that 6 times 7 times H is equal to 67HC. What do you think? I think Mo is incorrect. So in algebra, you need to know that the numbers must multiply each other. So 6 times 7, you have to actually multiply the number out. So it's 42 times h times c. But remember what we've learned in algebra, we don't leave the signs in. Okay. Are we going to write it like this? Is there a better way to write it? Okay. Which one would you like? Is it this one? Is it this one? Or this one? Well, you should know that in algebra, it's good practice. So take note of what I'm telling you now. It's good practice. You need to get into good habits of writing the letters in alphabetical order. So we'll choose the second one, 42CH. Okay, I would like you to now have a go at the rest of the questions. So remember what we've learned so far. What we've learned so far is that when you multiply numbers and letters, you actually multiply the numbers, and when you write it in algebraic form, you need to write the letters in alphabetical order. So for example, if I write 2 times 3 times D times C, 2 times 3 is 6. And then when I write C times D, I need to write CD. So I need to write it in the proper alphabetical order. So my answer will be 6CD. And then we also learned that if you divide in algebra, you need to remove the division sign. For example, C divided by 3 will be written as C over 3. So you write C, and then you put a bar, you put a line, and then you write the 3 underneath. Okay. So I would like you to pause the video and try to do this task in 4 minutes. So this gets you practicing writing things properly using algebra notation. Now remember, the title of our lesson is using letters to generalize numbers. So assuming you have paused and did your and you have paused and you did your work, here are the answers. Okay, so here are the answers. So remember, k times k is k squared. 3g means 3 times g will be 3, and then you write 3 next to the g. G plus g plus g is 3g. H divided by 3, you write it like this. Okay, and then 3 divided by h, you write it like this. 3, you put the line, and then you write the h underneath. And then y times 7 will be 7y. Yeah, that's a proper way of writing it. You write the number before the letter. Okay, and then j times k is jk. Notice how it's written in alphabetical order. Then 2m means 2 times m. M divided by 2, m over 2 means m divided by 2. M to the power 2. So notice the way I'm reading these, there is important you know them, is m times m. 2 over m means 2 divided by m. GH means G times H. H over G means H divided by G. Okay, and then notice this last one here for question 5. Just jumping back to question 5. You can see what I explained. 4 times 3 is multiplied first, and then you write the R next to it. Okay, I would like you to pause the video and have a go at questions 7 and 8. This should take you about 3 minutes. Now, I'll presume you have paused the video and you have worked through the questions. So make sure you do that because that's how you get better. So pause the video, work through the questions before you go through the answers and mark your work. Okay, so here are the answers. So m divided by 7, note the way it's written. You write m, you put a line, then you write 7 underneath. T squared means you write t and you put a little 2 on top. Okay, we can call this t squared or t to the power 2. So that's how we read it. 3 multiplied by r is 3, and then you write r next to it. K divided by m is k, then you put a line, and then you write m underneath. Okay, p multiplied by 11. Remember, we always write the number before the letter. So you write 11 and then p. P multiplied by 3 multiplied by y. Remember, you write the number, then you write the letters in alphabetical order. So you write py. And then here is this one. xy is the same thing as yx. Remember that word? Commutative. Don't forget. Okay, but the proper way to write it is xy. Remember y? We write in alphabetical order. But division is not commutative. We can't do this. I never told you that division is commutative. Okay, so take note of that. So that's the reason why the second one is not correct. That brings us to the end of our lesson. Okay, so far, what have we learned in this lesson? We have learned some really good fundamental knowledge, building our foundation in understanding algebra. So we have learned the conventions that you use to write algebra when you're dividing, when you're multiplying. We've used some bar models to do all that we need to do. So if you do not understand this still, please watch the video again, do the practice questions. Until next time.